Lesson 3.2 is on connecting percent and proportion. Starts on page 143. So example 1, basketball team statistician tracked the shots Emily made and the shots she missed during the last game. What percent of attempted shots did she make? Okay, so if you look, if you watch basketball very much, you'll see this a lot of times. They'll show where shots were taken from and then whether they were made or missed. What we can do is count up the makes and count up the misses. Okay, so if you count up the makes, the blue circles, there's 9 of them. There's 3 misses, so that means 9 makes, 3 misses, which means a total of 12 shots. So that means she made 9 out of 12. Okay, so 9 out of 12. There's different ways for us to find what percent that she made. The book's showing you one way, and then we'll talk about a different other way you could do this. So if she made 9 out of 12, we're trying to find a percent. We know percent is a number out of 100. So we can do a proportion. 9 out of 12 equals something out of 100. What the book says is they're dividing. Variables being divided by 100, so they multiplied by 100 on both sides. Multiply by 100, that's like 100 over 1. Gets those to cancel. And then that'd be 900 over 12. When you divide that out, you get 75, which means 75%. Another option that you could have done is the 9/12 actually is a fraction that could be reduced. So 9/12, both of those are reducible by?
3.
Good. Reduce both of those by 3 would be? 3/4. Okay. And 3/4, some of you might be familiar with to know that that is 75%. Okay. If not, you could still do the proportion if you're not familiar with that. At this point, there's actually a pattern you could use here. Going from 4 to 100 would be multiplying by 25. 3 times 25, 75. Okay. So that would be another option. One other option you have, giving you lots of options today. One other option is you could actually divide it out. 3 divided by 4. Understand if you were doing this by hand, the 3 is on the inside. Okay. This is what it would look like on your calculator sideways though, 3 divided by 4. And when you do that, you'll get 75 hundredths. That's a decimal. And then you just move your decimal over 2 spots. Okay? That's the most common way, probably the quickest way for you to find your percent. So like if you got a paper back from a class and they didn't write what percent grade you got like 21 out of 25 right, just take 21 divided by 25, get a decimal, and then move your decimal 2 spots. That's your percent. Okay? This can also be used to do things like if you play baseball, you can figure your batting average. Okay? With batting average, you actually, your walks don't count as your at-bats, you might be familiar with. And then you take how many hits you got divided by how many total at-bats minus the walk at-bats, and divide it out, give you a decimal. With batting average, usually they go to the 1,000th place. So you'd actually, different case there though, you would not move your decimal over for batting average. But if you did move your decimal over, that would tell you, move it over 2 spots, that would tell you what percent of the time you got a hit, not counting the times that you got walks. Okay? On base percentage figures in with the walks then. Between hits and walks, what percent of the time did you get on base? So these are a lot of practical applications associated with sports that we can relate to here. Going back to this last idea I was mentioning about the 3/4, good question a student had here is that going back to 9/12, if we would have stayed with the 9/12 instead of reducing it, that would give us the same decimal. Okay, so you don't even have to worry about reducing. Just divide it, get your decimal, move your decimal 2 spots. That's your percent. So look at the try it Camilla makes 2 out of 5 of her shots attempted. Is the percent of shots she made more than, less than, or the same as Emily's percent of shots? Okay, so if we're doing it like the book's showing us, we can set it up as the part over the whole. So she made 2 out of 5, and we're trying to find the percent. We know percent is a number out of 100. Good. Okay. With this, we've talked about before, if you go towards the variable, you can multiply or divide. Finding a pattern works a lot of times. So going from 5 to 100 would be multiplying by 20. So if we take 2 times 20 would be 40. Okay, so that would be 40%. The book did a little bit different here with filling in the blanks. I don't really know how valuable this is. They actually, in my book, did 2 divided by 5 and got a decimal and then put that over 100. I don't know if that's that valuable of a step there. I would just do the pattern and be done with it. Or like I said, we could just take 2 divided by 5 and you would get 0 and 4/10 or just 4/10. And then if you move your decimal 2 spots to the right, would give you the 40%. Okay, so anyway, she made 40% of her shots and the other person made 75%. So the amount she made is less than Emily's. And another good observation here, students being very observant today. 2 out of 5 that Camilla made, that's less than half. 2 is less than half of 5. The other person made 9 out of 12, which is more than half. So if we didn't specifically have to find what percent she made, just by knowing she made less than half, the other person was more than half, we would know that Camilla's percent would be less than Emily's. Example 2, a plan to expand Megan's room will make the length of the room 175% of the current length. What will be the new length of her room? Okay, so kind of a key phrase I've boxed in there, 175% of the current length. We have an option actually different than what the book's doing. What the book's doing is fine. They're saying let's put the new length over the old length. New length we don't know. Old length is 4. The new percent is 175. The old percent was 100%. And then they said they're dividing by 4. They multiplied by 4. You could do a pattern otherwise. Okay, going from 100 to 4 would be dividing by 25. You get the same answer that way. Okay, which would be 7. So 7 meters. Another option, like I circled or boxed in, 175% of the current length means 175% of current length is 4. So 175% of 4, and we could do like we did in the last lesson, just move your decimal 2 places to the left, 1.75 times 4, and you'll get 7 meters that way also. Okay, so again, different options, different ways that you guys can work this out and still get the correct answer. Example 3, nutrition label shows the percents of the recommended daily intake for nutrients found in a serving of soy milk. How many milligrams of calcium should you consume each day? So if we look at this, they've got it highlighted for us, the calcium. And you can see this is 20% for a serving, 20% of your recommended daily intake of calcium, and it also is 260 milligrams. Those percent daily values are based off of so many calorie diet. I think it's like a 3,000 calorie diet. Some people might not have that many calories. They might not be eating that much. Like if you're 2 years old, maybe you're not eating that much. If you're, like a teenager, you might be eating more than that. You're growing and stuff, so you need more calories. But anyway, so everybody's got different amounts of calories that you might need to be consuming in a day. But anyway, that's based off of whatever that is, 3,000 calories, I think. So one way we can do this, again, if you take the part over the whole, 260 is the part, the whole we don't know. 20% we know is 20 over 100. From that point, I don't really care for how the book did this. It's not a good practice for you to multiply by a variable. So we're not going to get in that habit, so let's just forget about that. What I would do is just look for a pattern. Going from 20 to 100 would be multiplying by 5. So 260 times 5 would be 1,300. And we don't have to develop any bad habits that will not be good for us later in math when we're solving equations. Okay, so this is one option for doing this problem. Another option that you have for setting up a proportion, you could do C for calcium for 100% equals 260 milligrams over 20%. The percents you don't technically have to have, but I'm just showing you guys. Basically, if we're just putting this as the milligram over the percent, and then basically it works the same as what we just did. There's a pattern multiplying by 5, and we'll get 1,300. Okay. Another observation a student made here is 20%. If you know 20% is 1/5. If you have 1/5, then means you need to multiply by 5. So 260 times 5 would be 1,300 milligrams as well. So if we look at the try it, part A, Megan's room is expanded so the width is 150% of 3 meters. What is the new width? So they kind of gave it away here in a way. 150% of 3 meters. 150%, we could just change that to a decimal. Of usually means multiply, so 1.50 or 1.5 times 3. And that would be 4.5 meters. If you got more than 100%, make sure your answer is bigger than what you started with. Okay. Part B, using the soy milk label in example 3, what is the recommended amount of iron needed each day? So iron, you can see 45% is 8 milligrams. So you could say, we're trying to find iron. Maybe we'll do a capital I for iron. We're trying to find the iron that's 100% if 8 milligrams is 45%. These numbers might not be quite as nice here. You could potentially find a pattern if you're using a calculator or something, but otherwise, if you wanted to just work it out, you could. That'd be 800 over 45. And then when you go to divide that out, and you should get 18. So again, with a calculator, maybe you could find a pattern there, but again, we don't always get to use a calculator, so make sure we know how to work it out by hand also. Other fraction, another way you could have done that would have been 45 over 100, the part over whole that we talked about. 8 would be the part, and then our I or whatever variable would go in the denominator. Okay? Either way you work that out would be fine.